The last episode was about the incredible new high-resolution image of the sun, but the timing's perfect. We've got the launch of the European Space Agency's Solar Orbiter spacecraft, which is going to join the Parker Solar Probe and the Daniel K. Inouye Solar Telescope to take the highest, most detailed images of the sun from every different perspective. So our view of the sun just is going to get so much better in the coming years.
5, 4, 3, 2, 1, 0. And liftoff of our solar orbit.
On February 9th, 2020, the European Space Agency's Solar Orbiter spacecraft launched from Cape Canaveral, Florida, on top of an Atlas V411 spacecraft. The spacecraft's mission is to fly inside the orbit of Mercury on a tilted orbit that takes it above and below the sun, capturing images of the sun's poles for the first time. This is just a year and a half after the launch of NASA's Parker Solar Probe, which will fly even closer. Together, the two spacecraft will measure the sun from every angle up close, providing detailed images and insights of our closest star to help understand how it creates and controls the giant bubble of plasma that surrounds the entire solar system. With the successful launch of Solar Orbiter, the first destination will be a flyby of Venus to shift its orbit. Then another gravitational flyby of Venus, and then a return to Earth in 2023. These and many following flybys will slowly shift it into a highly elliptical orbit, one that takes it above and below the solar system's plane of the ecliptic. It'll make its first close solar pass in 2022, coming within 50 million kilometers of the sun. And its trajectory keeps it in resonance with Venus, returning to the planet in 2025. Each pass will increase its orbital inclination by a few degrees, getting to 17 degrees within the main mission, and reaching 33 degrees during a proposed mission extension. Each orbit will allow it to peak higher and higher over the sun until it can finally see the regions around the poles. This isn't the first time that a mission has flown above or below the plane of the ecliptic to study the sun's poles. NASA and ESA's Ulysses mission was launched in 1990 with the same goal, studying the sun's polar environment and tracking the power of the solar wind. Ulysses used a gravity-assisted Jupiter to kick it into an orbit that carried it as high as 80 degrees above solar latitude, and its closest point, it got within 200 million kilometers of the sun in 1995, still farther than the distance from the sun to the Earth. This mission was a tremendous success, operating for year after year, observing both poles of the sun and providing scientists with a wealth of data about our star and its polar regions. Mission controllers finally lost contact in June 2009, ending 18 and a half years of a successful flight. The big difference between Ulysses and Solar Orbiter is that the new mission will be much, much closer, allowing it to make many more orbits and watch how the sun's poles change dynamically as it shifts through its 11-year cycle of solar activity. And it'll also have a camera on board, so this time we'll actually have pictures of the sun's poles. Although the $1.5 billion mission is mostly funded from the European Space Agency, NASA has been heavily involved in the construction and operation of the mission, overseeing the launch from Cape Canaveral and helping to build several of its science instruments. Solar Orbiter is trying to help scientists learn more about 4 big unsolved mysteries about the sun. First, what drives the solar wind and where does the coronal magnetic field come from? There are electrons and ions pouring from the sun in all directions. How the solar wind helps to heat the sun's corona to more than 1 million degrees. What is the mechanism that does this? Next, how does all the activity on the surface of the sun contribute to its variability? You might not realize, but the sun is actually a variable star, changing its solar output by about 0.1% over its 11-year solar cycle. How do all the flares, coronal mass ejections, and prominences contribute to the variability? Next, scientists want to understand how the sun creates the heliosphere. This is a bubble that surrounds the entire solar system, so far that the Voyager spacecraft took decades to escape it. The sun is accelerating particles off the surface at close to the speed of light, which can damage our spacecraft here on Earth. Finally, how does the sun's solar dynamo work? The sun's magnetic fields are constantly twisting and turning, and over the course of an 11-year cycle, the orientation of the poles actually flip. In theory, the flows of hot material bubbling up through the convective zone should help scientists understand how this is happening. Solar Orbiter is equipped with 10 different instruments packed into the spacecraft, and I won't go into all the details, but I'll provide a link in the show notes if you want to dig into their capabilities further. In general, there are two types of instruments, in situ and remote sensing. The in situ instruments will help make their measurements around the spacecraft, detecting the particles streaming from the sun, the magnetic environment, etc. The remote sensing instruments will observe the sun from afar, measuring its surface and atmosphere in all the different wavelengths. Of course, getting this close to the sun means the spacecraft will need to deal with extreme temperature and radiation in the inner solar system. Engineers have a clever solution for this, which I'll get to in a second, but first I'd like to thank William Minibet, Jack Saunders, Randall Sylvia, and the rest of our 844 patrons for their generous support. Join our community at patreon.com/universetoday. Unlike the Parker Solar Probe, which will get within 6.16 million kilometers from the sun, Solar Orbiter will only get as close as 42 million kilometers, about 1/4 the distance from the Earth to the sun. But this is still much closer than Mercury gets, and the intense radiation from the sun is 13 times more powerful than what we experience here on Earth. Without any protection, its electronics would melt. So, engineers had to come up with a strategy to deal with the heat. The spacecraft is equipped with a 3-meter wide, flat black sun shield that it continuously holds up between itself and the sun, with tiny portholes that it can peep through. The sun shield itself is made of a titanium alloy that's only 0.5 millimeters thick, about the width of a human hair, but it's then painted with a flat black coating. And I'm sure you're wondering, why flat black? If you want to keep something cool, why would you paint it black? This coating has to do 3 jobs. It has to keep the exact same color throughout years of operation. A white or reflective coating would be great, but it would darken over time, changing the thermo-optical properties of the spacecraft. So the team settled on black. It has to be electrically conductive to prevent a buildup of static through the interaction with the sun's solar wind. And it couldn't outgas or shed any particles that could damage the sensitive optics or instruments on board. They used a coating developed for titanium medical implants that embeds the pigment right into the metal. Their technique was so effective on the heat shield that they expanded the process, painting every part of the spacecraft black that they could, even one of its science instruments. Then they modified the process to produce a white pigment that could be painted on the radiators to get rid of all this heat off the spacecraft. 80% of the spacecraft has now been painted either black or white using this technique. The sun is such a constant presence in our lives, and yet there are still so many mysteries about it and how it creates the dynamic environment that surrounds the entire solar system and has a direct impact here on Earth. It's good to know we've now got 2 spacecraft on the way to help us learn more about it and how it works. What do you think? Let me know your thoughts in the comments. Here are the names of the patrons who support us at the $10 level and more. Want to see your name here, support the work we do? Go to patreon.com/universetoday. Once a week, I gather up all my space news into a single email newsletter and I send it out. It's got pictures, brief highlights about the story, and links you can find out more. Go to universetoday.com/newsletter to sign up. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up right on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. We did a whole video on the Parker Solar Probe too, so if you want to know more about that mission, you can watch this video now.